Hello everyone. Today I'm making a quick tutorial on how to sketch Bode plots for any transfer function. But before we do so, we should know that the Bode plots are usually used for analyzing the frequency response of a transfer function. So sometimes whenever we design a microcontroller, we need it to meet certain specifications or specs. And in order to do so, we need to analyze the frequency response. So let's talk about how we can sketch the Bode plot for a given transfer function. Oh, the video clip. Okay, so we're going to put the function in Bode form. This is how we put a transfer function in Bode form. So we need to extract the 2 because we want to have s plus 1 everywhere. So we're going to do times 2, and then we're going to have 1 plus, or not s plus 1, just 1 plus a factor of s. So here we're going to have s over 2. Divided by this s we can leave alone, but now we have s plus 10. So here we're going to multiply by 10 and have 1 plus s over 10. The 10 cancels out with the 2 and 5. Now we're left with 1 plus s over 2 divided by s times 1 plus s over 10. Now the reason why we put it in this form is because we can rewrite it like this now. 1 plus s over 2 times 1 over s. You could put it in whatever order. This is just an example. 1 plus s over 10. Okay, so this is our transfer function. Now, the reason we want it in this form is because we have a formula sheet that tells us how each of these components react in, or how they behave in the magnitude Bode plot and in the frequency or the phase Bode plot. So here, let's start with, for example, 1 over s. 1 over s contributes negative 20 log omega in the magnitude Bode plot. Then we have 1 over 1 plus s over 10. That contributes negative 20 log of omega over 10. This you get from the table. So I'm just writing it down so that we could graph it after. And then it's 0 otherwise. And here, lastly, we have 1 plus s over 2, which gives us 20 log of omega over 2 for all omega greater or equal to 2, and then 0 otherwise. Okay, so from here, we can start sketching the magnitude plot, magnitude Bode plot. I actually kind of prepared it in advance, so I'm just going to copy paste it just so it's neat and I don't have to draw it out completely, but it's not done. Okay, so as we can see, the 1 over s is just negative 20 log of omega. I decided to start my omega axis at 0.01. Keep in mind that this axis is strictly supposed to be like frequency value, so just try to have multiples of 10. This is like 10 to the 0, and then 10 to the 1, 10 to the 2, and then we have the negative, 10 to the negative 1, 10 negative 2. And then from there, you can start drawing the Bode plot. So for the integrator 1 over s, we have negative 20 log of omega. So we're just going to type that in our calculator, like negative 20 log of 0.01, that gives us 40. And then because it's negative 20 as the coefficient, just a little trick is you just go down 20 dB per decade. So yeah, I wrote it down right there, and that gives us the 1 over s. Now for the other ones, like the 1 over 1 plus s over 10, and also the 1 plus s over 2, which is our pole and our 0, you have to draw out, like, you have to sketch that they are 0 anywhere before. So for example, like the 1 over 1 plus s over 10, it's going to be 0 before 10. And then for all values greater or equal to 10, it's negative 20 log omega over 10. So you could put the first value in your calculator and then again just negative 20 dB from there. So that's what we get. Now at the end, what we have to do, I'm gonna do it in white. We have to draw the final boat plot. That's why we kind of decompose it first, because it would be too difficult to keep track of everything. So now we know that, sorry, we have to start at 40 because the other functions are 0 elsewhere. Like this one, I forgot to put it, but it's 0 all the way till here. It's 0. So we start at 40, and we could see that there's nothing else. Everything else is at 0, so it keeps going 40, 40, and going down negative 20. Okay, at here we get to 2, and now we have plus 20 dB. But before that, we just had negative 20 dB, so starting from 40. So we just go negative 20. And now at 2, we see that we have plus 20 dB. So negative 20 plus 20 is 0. So up until this point here, it should just be 0. And keep in mind, this is just sketching. It's not the actual values. It's just a sketching technique. And then from 10, again, we have negative 20 dB. So the final boat plot would look something like this. That's it. And what you need to, also a good thing to keep in mind that you'll need later on is knowing like the limit as omega approaches 0 minus, we get infinity, magnitude of g of s. We get infinity because if we were to put like 0.001 and then 0.0001, it just keeps going up. So it would go up to infinity, but as we have the limit when omega approaches infinity, we could see that it's going to negative infinity. So this would be for the magnitude boat plot. Now let's draw the phase. Again, we have to look at our table. I'm just going to go get those values real quick. Okay, so I completed the table for the transfer function's phase boat plot. Now we just need to fill it out. So from the integrator, again, we have negative 90 degrees. So this one is just permanently 90 degrees, or negative 90 degrees. So we could just write it like this, and it just goes on forever. So this is the 1 over s. Now, for 1 over 1 plus s over 10, it's a piecewise function. So it says that it is 0 for all omega less than 1, less than or equal to 1. So I'm going to do this one in blue. Anything before 1 is just going to be 0. Then it needs to go negative 45 by the next decade. So it should be negative 45, and then negative 90 by the decade after that. So all the way down here about. Again, this sketching does not have to be perfect. But my OneNote does not like to listen sometimes. Come on, there we go. Should pass like this. And then when it's at negative 90, it'll stay like that. So it should just go straight afterwards. So like this. There you go. And that was which one? 1 over 1 plus s over 10. Here you could write it. I don't know if it's mandatory. Sometimes people like to have it. You could write negative 45 degrees per decade. Okay, and for the last one, do it in red. It is 0 up to 0 0.2. 0. And then 45 degrees at the next decade, so here. And then at 20, it should be at 90 degrees, which is here somewhere. Okay, just sketch it, plot the line. There we go. Here we have 45 degrees per decade. And then after that, it just stays at 90. Okay, so we have the decomposed boat plot. Now we have to put it together. So if we look at this graph, we start, everything is at 0 except the integrator that starts at negative 90. So I'm going to draw a line that goes up to this 0 0.2 right here. Okay, then we have plus 45 degrees up to 1, because at 1 we have something that changes. So up to here, I'm just going to go 45 degrees. Now notice that from 0.2 to 1 is not a full decade, so it never actually reaches negative 45, even though it has a slope of 45 degrees. Because the next decade would be at 2, it would be negative 45 here. But because we stopped, it would just stop right here. Okay, and now we have, again, negative 45. So because we just went from plus 45 and now we have a negative 45, it just goes to 0. So we could just say that it stops right here. Okay, so this is our slope. And sorry, rewatching that clip, I actually made just a small mistake. It is a slope of 0, but it isn't a slope of 0 forever, because here we get it settles at 20, but here it settles at 100. So what's going to happen is, let's go till 20 with the slope of 0. So like this, about here. Okay, so we have a slope of 0 up to 20, and now you can see the blue line still has that negative 45 degrees up until 100. So from 20 to 100 is almost a full decade. So it almost goes back to 90, to negative 90. So it goes like to, like, let's say negative 80 degrees. Let's do it like this. Okay, it's not drawing it straight, but it's fine. Just like that. And then it settles. Okay, so it kind of goes up and then has a slope of 0, and then again, a slope of negative 45. Here we could just write it out. Here it's 45 degrees per decade. And then we have 0. Then from here, we have negative 45 degrees per decade. And then again, we have 0 degrees. Okay, so that'll be the phase Bode plot for this function, transfer function g of s. All right, so that's it for this video. If you need more explanation or have any questions on transfer functions and their Bode plots, reach out to me on the email. I'm going to put it up on the video. And that's it for this one. Take care, guys. Bye.